Today we'll discuss about that free radical substitution reactions. So what are the compounds involving free radical substitution reactions? Generally, alkanes are saturated compound involving free radical substitution reactions. Free radical substitution reaction takes place in the presence of sunlight or peroxide medium or thermal condition. Thermal means it is close to 400 to 500 degrees centigrade. So in this temperature, so always involving free radical substitution reactions of alkanes. Free radical substitutions of alkanes. For example, we have to discuss about that methane. Methane reacted with the chlorine in the presence of sunlight or peroxide medium, hydrogen peroxide or any peroxide. Just it is a hydrogen replaced by chlorine. Can I call this is a substitution reaction? Yes, this is a substitution reaction. Hydrogen replaced by chlorine. So it is actually three steps mechanism. So I will discuss here mechanism. That step one initiation. Initiation means formation of radicals. Formation of radicals. Here chlorine in the presence of sunlight, here homolytic fission takes place. It forms radical, chlorine radical, then chlorine radical. Again one more is a step 2. That is a step 2 is a propagation. Propagation. Here it is a propagation means chain length increases. So here hydrogen. This is actually methane, CH4. It is react with a chlorine radical. It form CH3 dot with HCl. Means this is again homolytic fission. This is also again a homolytic fission because of that previous step. It depends. The second step depends on the previous step. Previous step it form the radicals, chlorine radicals. So that here also it form the homolytic fission takes place. It forms CH3 radical with HCl. Again that CH3 radical. Again CH3 radical. I have to discuss here. So CH3 radical. That second step CH3 radical. CH3 radical with again chlorine. It forms CH3Cl with chlorine radical. Again step 3. That is the last step. Step 3. That is termination. Termination means you have to stop the radicals. Here chlorine radical first step. Again this chlorine it forms Cl2 gas. Again one more is a methyl radical. Any unwanted unreactive methyl radical it converted to ethane. But these two are always minor. So major product is CH3Cl. It form only propagation step. So in this case I have to discuss about that examples. Few example free radical substitution reactions. So free radical substitution reactions. So here for example here we are taken butane react with the chlorine in the presence of sunlight. So here how many types of carbons are there? Here two types of hydrogens, two types of carbons. This one and this one both are primary carbons. So this center one, these two are always act as it is a secondary carbon. So it is purely depends on types of carbons. So here two types of carbons are there. It form two products, Cl with again Cl. Here it is a 1-chlorobutane. Here it is 2-chlorobutane. So in this case, so radicals, stability or reactivity of radicals, always a tertiary radical is more than secondary radical than primary radical. According to hyperconjugation, that here 2-chloro is a major product, major one, then this is minor one. Sometimes they are asking a question, they will give the allylic carbons like see here CH3, then CH double bond CH2. In this case, chlorine in the presence of sunlight, again chlorine in the presence of delta, again NBS, again NCS. NBS means that is N-bromosuccinamide. This is a brominating reagent. N-bromosuccinamide. So NCS means N-chlorosuccinamide. This one is a NCS. This is a NCS, N-chlorosuccinamide. Here chlorine in the presence of sunlight, always this is a vinylic carbon. This carbon is we are calling as a allylic carbon. Allylic hydrogen replaced by chlorine, so that it is a free radical substitution reaction CH2. Same thing it's happen under sunlight, under high temperature. This is generally we are calling thermal condition CH2. Again NBS also, it is a brominating reagent CH double bond CH2. Here chlorinating reagent, it is also same CH2 double bond CH2. Again, one more question I had to discuss, that is a benzylic system. So what happened in the benzylic system? So this is a discussion in previously, this type of the questions they are asking in entrance exam. So here we are taking CH2 CH3. So in this case, so chlorine in the presence of sunlight, again chlorine in the presence of delta, then NBS, then NCS, then chlorine in the presence of AlCl3. So first case, so this is we are calling as a benzylic carbon, benzylic carbon. So this one is a normal carbon, normal carbon. So here benzylic carbon reactivity order of free radical substitution, always benzylic carbon is more than allylic carbon, then tertiary carbon, then secondary carbon, then primary carbon, then least is a methyl group, methyl free radical. This is actually reactivity order. According to this one, this is a more reactive, so that hydrogen replaced by chlorine, then CH, CH3, Cl. Similarly, CH, CH3, again benzene, again it forms chlorine. So NBS means that is a brominating reagent, then CH, CH3, Br. So here also same thing, this is this one, then CH, CH3, Cl. Whereas in this case, Cl2 AlCl3, it is a electrophilic substitution reactions. Whenever it is electrophilic substitution reaction, it is acting as a plus Me group. Whenever it is a plus Me group is direct attached to benzene, electrophilic substitution takes place at ortho and para position. So it is form a orthochloroethyl benzene, then para chloroethyl benzene. Thank you.